we're going to go ahead and talk about how to solve an AP Physics C Mechanics free response problem from 2022, and this is from set number 1 and it's number 2. What I would encourage you to do, go to the College Board website, download this problem, try it yourself, and then you can check back on the video which explains how to do it. Okay, so now that you've done that, let's go ahead and talk about how to solve this problem. Okay, so you've already read the problem, so let's just go ahead and look at A together. Okay, so during the collision, is the impulse on cart 1 from cart 2 greater than, less than, or equal to the magnitude of the impulse on cart 2 from cart 1? Okay, that looks just like a Newton's third law thing. For every action, there is an equal but opposite reaction. And again, because impulse is force times change in time, the time interval is the same. Each one experiences the same force. Cart 2 pushes left on cart 1, and cart 1 pushes right on cart 2, but it's the same force, so it is going to be equal to. Okay, so part A is just worth 2 points. It is going to be 1 point for equal to, and then it was going to be 1 point for correct explanation. Okay, so let's go ahead and chat about B now. Go ahead and ignore what was just on the screen for B. Let's go ahead and just talk about this first. So TC, again, means the time of the collision, when the collision occurs. One thing, which that was my silly mistake when I did this problem last time I did it. One thing to keep in mind, silly, is M2 is going to be greater than M1. So keep that in mind for this whole problem. Okay, so when this problem starts, let's go ahead and look back to the original problem. The cart 2 is initially at rest. Cart 1 starts at rest, but then it's going to have some velocity right before it hits cart 2. Okay, so that means for cart 2, it's at rest before the collision. It's at rest the whole entire time. Cart 1 starts at rest, so I'll go ahead and draw a little dot here. Okay, and let's just say cart 1 has a final momentum of this. So I'll go ahead and draw that on there like that. Okay, so now let's worry about after this. Okay, so after the collision, cart 1 runs into cart 2. So there's going to be more mass in the system. So cart 1 is going to slow down. And again, they're connected. So let's say it goes to about right here. Cart 2, on the other hand, that is going to speed up. So let's say that goes to about right here, this point right here. Okay, let's go ahead and chat about the rubric for this one. This is a tricky little one. Okay, so this is actually out of 4 points. So you get 1 point for correctly identifying what the momentum is before and after the change. I'll go ahead and do another color. You get 1 point for recognizing for cart 1, the momentum is less than what it was when it right before the collision, and that it is constant afterwards. It's one horizontal line. Okay. And you also get 1 point, we'll do that in a different color, for recognizing that cart number 2, also the momentum is constant after the collision, and that it has a bigger momentum than cart 1 because cart 2 is more massive than cart 1. And the last point, and this is a tricky one, so we know that this one, okay, so we know for our last little point, and again, this is the trickiest one, we know impulse equals change in momentum. So this one, cart number 1, lost the change of momentum is this. So that's the impulse that it received. So that needs to be the same, the momentum amount that changes by needs to be the same as the momentum gained by cart 2. So those two need to be equal, and that is where you get your last point in this problem. Okay, so our last little part of this problem, we want to find the velocity of the 2-cart system after the collision and prove that it is equal to this little nifty equation right here. Okay, anytime there is a collision, we need to use momentum conservation. So let's go ahead and look at the collision part. And again, for the collision part, we need to isolate it like right before the collision and right after. So the initial momentum equals to the final momentum. So right before the collision, if we look at this, cart 1 is going to be moving, let's say some speed v1. Cart 2 is at rest, and then after the collision, they are together. So this is our after picture, and they're calling just v both v. So let's go ahead and set up a momentum equation to show this. So that is going to be mass 1 times whatever that velocity is, 1 beforehand, plus it's going to be mass 2 times that one is originally at rest, so that's 0, equals mass of both of them, so m1 plus m2, times the velocity of both of them, which they're just calling. And again, I'd go ahead and write to the side. This just stands for v both. Perfect. Okay, so we need to show, so that's not quite the format they wanted in. We need to figure out what v1 is right before the collision. So we're just looking at number 1. So I want you to think about what's a good strategy to use if something is changing height and changing velocity. Honestly, first bet most of the time is energy conservation is going to be your best bet. So let's just go ahead and set up energy conservation. So we're just looking at cart 1. So at the top, so we're looking from the top of the hill to down here. Well, at the top of the hill, it has gravitational potential, and at the bottom, it has kinetic energy. Let's go ahead and set that up. So it'll be UT where we got, it'll be M1 GH equals what? 1/2 M1 V squared. And this will be V1 squared. So let's go ahead and simplify that. M1 cancels out. V1, when we do the math, is going to be square root of 2GH. So we can go ahead and plug that in over here. So now let's go ahead and rewrite this. So it's going to be M1 times square root of 2GH plus the second term will just cancel out because that's 0 equals M1 plus M2 times V. Okay, last thing we just need to do is divide by M1 plus M2. And we got our answer. Great. So our answer is just, oh, sorry about that. So our answer is just going to be M1 times square root of 2GH over M1 plus M2. Great. And they just went ahead and rewrote it slightly different. They moved the square root of 2GH up front and then the H outside of it, which you'll see why in a second, but either format is going to be the same format. So let's go ahead and go through the, okay. So for this one, you get 1 point for using momentum conservation for this problem. You get another point for using energy conservation to find the velocity of cart 1 right before the collision. And then you get 1 point for combining those two equations together correctly to get your final answer. So kind of 1 point for like putting all the ideas together. You could also use like kinematics equations too for this one. I like energy conservation. I think it's the best bet for that one. So that is out of 3 points. Okay, let's go ahead and go on to the next one. Okay, so for this problem, we got to, for I, we got to draw a best fit line. Again, if you're drawing a best fit line, make sure to take a piece of paper or a ruler or whatever just to make sure it is a nice straight line. But I'm going to go ahead and pretend I had a perfect piece of paper for that. That's actually pretty good to eyeball it, but again, you're using a ruler or a nice piece of paper for that whole thing. Great. So this one, this is just 1 point for this one, and to get a 1 point for that, it needs to be a straight line, and it needs to have about the same number of points above or below your best fit line. Okay, let's go ahead and look at now. Okay, so now for 2, it says use the best fit line to calculate the mass of cart 2. So a key is if you're using the best fit line, you're going to need to find the slope of that line. So let's just go ahead and look at this problem. And again, you need to find 2 points on that slope. It could be data points if the data points are on the slope. So like this one is on it, but I'm just going to use like this point right here is an easy one for me and this point right here. So slope again is rise over run. Rise over run. My rise, so I rise up by 1. And my run is going to be over by 0.6. So 1 over 0.6. That is going to be about, what is that going to be? 1.66 when I put that in my calculator. Okay, so using best fit line in our previous equation, we're going to need to use those ideas of linearizing. So let's go ahead and go back to our equation from the previous one. So again, that equation is, okay, so again, the equation for C is going to be V equals square root of 2G times, this is M1 over M1 plus M2 times the square root of H. Okay, so if we're going to use our linearizing techniques, we can use our equation y equals mx plus b. Okay, so now let's go ahead and compare. So we know that the y variable is like v in this case. So again, that's like v. The x variable, sorry, I keep doing that. The x variable is going to be like square root of h, matching up. So then m again stands for our slope. So our slope is going to be everything left over. So our slope for m is going to be equal to square root of 2g times m1 divided by m1 plus m2. So now let's just go ahead and plug in what we know. So the slope was 1.66 equals square root of 2. G is just 10, or you could use 9.8 meters per second squared. M1, I think they give us M1. So M1 is 0.25 over 0.25 plus M2. Great. So now we just got to do some fun math to find M2. And when I went through my math, I got M2 to be 0.42 kilograms. Okay, let's go ahead and go through the rubric for this one. Okay, so this one is actually out of 3 points. So you are going to go ahead and get 1 point for correctly finding the slope. And again, to correctly find the slope, you need to use 2 points on your best fit line. So again, I do the stars right there. It could be different points that you use than me, but they need to be on it. So if you use this one right here, that is not on your best fit line, so that would be incorrect. Okay. You get 1 point if you relate the slope to the best fit line. So kind of this whole idea right here is worth another point. So kind of finding that slope and relating it. And then it is 1 point for your final answer. Again, there is a range of answers. If you get anywhere from 0.3 to 0.6, then that would be correct. Okay, let's go into our last. Okay, so let's go ahead and just take our equation from the previous one to help us with part E. So we found that the slope is equal to square root of 2g times m1 over m1 plus m2. And again, I got for my slope it to be 1.66. You might have gotten a different one, so, whatever slope you got. So 1.66 equals square root of 2g times m1 divided by m1 plus m2. I'm going to go ahead and manipulate that to solve for m2. So, okay, so if you do some math on this, you'd get m2 equals what? Square root of 2g m1 divided by our slope, which I got 1.66, take away m1. Okay, so if m1 decreases, so if we look at this as m1 is decreases, which is what they're saying, then m2, so m1 over here decreases, then m2 has to decrease. So then the correct answer would be this. This one is just out of 2 points, and it is going to be 1 point for checking the correct box, and 1 point for a correct explanation. So just out of 2 points. And again, if you're short on time on the AP exam, just make sure to check a box just so you can get at least, you get at least a 33% chance to get it correct. And again, my general AP rubric is if you're getting between 9 to 15 points total, that's around an AP score of a 5. If you got about 7 to 8 points, that's about an AP score of 4. 5 to 6 points is about an AP score of a 3. If you're getting around 4 points, that's an AP score of 2. And 0 to 3 is an AP score of 1. So kind of just use that as a guide. And again, the more and more you do these, the better and better you will get at them. Awesome. Thanks for watching.